Hi, this is Rahul. In this lecture, I am going to discuss the Bfs algorithm. In Bfs algorithms, the full form of Bfs is base first search. There we search one vertex of the graphs. So, suppose we have a graph, we need to first migrate in adjacency matrix. So I will use the representation of adjacency matrix to make a Bfs algorithm. So we have a graph of size. You can see here 5 vertices. We have 1, 2, 3, 4, 5. Now, how do we actually migrate this graph into adjacency matrix? You can see we have two type of entities in this matrix, 0 or 1. When it is 1, if rows and columns, corresponding row and columns, these are adjacent in this graph, then we are filling 1. 1 is 1 and 2, these are 2 are adjacent in this graph, so that is the reason we have filled here 1. You can see 1 and 2 one's columns and second rows, these are adjacent. That's why we put this entry as a 1. So this way we use this representation to make this Bfs algorithm. In the beginnings, we will start with the empty queue. If you don't know empty queue or the operations with empty queue, I will tell you. Suppose we have array 1 2 3, and there are two operations which is performed with the queue data structure. First one is in queue operation, in queue operations. Second one is a dequeue operations. This is what adding any element in this array, and this is what removal one element from the array. What it means, if you want to remove any array from this, any element from this array, what will you do? You can remove from the beginning. If any element, suppose if you have performed the dequeue, you will remove this one, right? You will remove which one? Sorry, this one, right? Suppose if you want to perform in queue operations, you will add at the end of this array. So these are the two operations which will be performed with array. Then the array is called as a queue. This is very simple one, right? Now what we'll do, initially on the whole graphs, we have not explored any vertices, so that's why we take one array here, explode array, and we will put all the vertices which are present are marked as a not visited, means not with 0. So what it means, then in the beginnings we go all the vertices of this array. V is what? Set of vertices in this graph. So we can write in another way. We can, V is equal to what? 1 2 3 and 4 and 5. These are the vertices in our graph. So that's why I am going on each vertices in this graph and mark all the vertices which are all the vertices which are not explored, so by 0, right? So initially there is no vertices of this graph is explored, so that's why we have put in here 0. I hope this is clear. Now we will move to next iteration, which is NQ. We perform NQ. Why do we perform NQ? Because we are going to explore the searching. We are going to explore the vertices from any random time, random vertex. Anyway, we have to visit our, suppose somebody asked to search this 3 vertices, then we have to enter from somewhere. So like that, from here we may enter from here and directly we can go. But if we assume that if series 3 is means asked to search, then we start from any random vertex, right? So suppose u is a random vertex in this graph, we will figure it out. V as a random vertex, so we can put it directly by 1, because 1, I know one is one vertex in this graph, so that's why we have put in 1, right? Now we repeat the exploring of vertices. This is, in this process, what we are doing, exploring the vertices of any neighbors of any vertex. So you can see we have here in Q1 one at least one vertex in this Q. Now we will see and at this moment of time there is one element was there, so that's why q is not empty. 5 means what? Empty, right? So we will remove one element from the queue. What it means, the queue, as I explained here, we remove first element from this array, and what we do, we mark is as a explode, right? And we go all the vertices of the graph and see if any vertex is a adjacent of this one. What it means, we are going all the neighbors. So when it is one, when there is a all the when these columns are neighbor of this row, so that at that moment of time those vertices are adjacent, right. See, we are visiting all the neighbor of v, because if there is age u to v, then there must be entry 1, so that is this is confirming the age, right? Next, if the vertex u w is not explored, in that, if this condition is true, we will move to the next instruction which is going to be executed. What is this instruction? This instruction is saying we are enqueuing w. What it means, we are adding w to the queue. So now once we enqueue w to the queue, what will we mark w as a explored vertex, right? We repeat this process until when at any moment of time, what we will see, the elements of this queue will start decreasing. What it means, once we have explored all the vertices, at that moment of time no vertices will going to be explored, because we are keep on marking here all the vertices. So this is any point of time these instructions will not get executed or will not get true. So if this statement is not going to be executed from the any moment of time, so what will happens, we always dequeuing one element in each iterations. Any moment we will get q empty. So once we get q empty, what it means, we will assume that all the vertices of these graphs are explored. But how this algorithm is actually working? So if we start from one, let's say I take same pictures, I copy this graph here, how this algorithms work, right? I copy it again here, this side. You can see right. We have you can see here we have algorithms, and we run these algorithms for this graph. So we started from one, right? You can see we started from one vertex. Now we have we added this one vertex to the array or queue. So the next neighbors we will move to this one iteration. What we see, there is no queue is not empty. Now we will remove this one. Suppose we have removed this one, and we go all the vertices of graphs. You can see we will move to all the vertices, and when see there is a entry 1, what it means, either u and v, if they are neighbor, then there is 1, otherwise 0. So what it means, we are moving toward the neighbors. So 2 and 4, these are neighbors, and 2 and 4, these are initially not explored. So that's why the entry which was initialized, it was 0. So that's why we will explore the neighbors 2 and 4. Suppose we have explored, right? In next iterations, and same times, what we will do, simply enqueue in the array. So in queue, how many members would be there? Numbers 2 and 4, right? Later, now next iterations, what we do, we simply remove this one, and explore its neighbors. Let's see what are its neighbor. 3 and 5 is also neighbors of 2, right? 5 is also neighbor of 2. What we'll do, simply what we see in queue, how many elements should be? 4 and uh, 3 and 5. In this way we can fill this queue, because these are the neighbor of 2, 3 and 5, these are the neighbor of 2. That's why we have added in queue by using these operations these two elements, right? Later on what will happens, now we'll remove this one, right? What we see, we start exploring vertices. What we see, the neighbors of 4s. What are those neighbors? 1 2 5. What we see, all those vertices, once we have include in this area. What it means, when we have include in this area, what in the same moment of times we have marked also the vertex was explored. So that is the reason. So we do not move to the neighbors, or we do not enqueue against to the queue, right? So that's why we will not move from here to next vertex, and we simply dequeue this area, right? So area, this queue will become 3 and 5, right? In the next iterations, what will happen, is there any neighbor of 3 which is not explored? What we see for 4 and 5, you can see 2 4 and 2 and 5, these two vertices which was already explored. So what we'll do, simply don't do anything, because this condition become false. So if the and means what, if both conditions are true, then these instruction will be executed, otherwise no. So now what we see, in next moment of times, if we have explored this one, the array will becomes, or q will becomes 5, right? Because let's see, any vertex, any neighbors of this 5 or 5 which are not explored. See, let's see, in this graph what we see, 4 4, sorry, 4 5 2 3, these are all the vertices we have explored before. So that's why we do not not need to add any element this queue. So we will not move here, because all no vertices which are explored, which so in the next iteration what will happen, q becomes empty. That's we want. When q becomes empty, these conditions become wrong, and we will move here. And that way, when we are dequeuing, we can print it out. Sometimes question been asked, the print, how the print, the iterations or traversing of the Bfs. So how do we actually present? Where you will write print a statement, you can write over here. Here you can write print a statement. Print what? Print v. This one. I hope this is clear. If you find this lectures helps you to understand Bfs, then please like and share with your friend.